Hi everyone. In today's video, I explicitly wanted to demonstrate how the mining works in blockchain. Now to understand the mining, let's first simply understand how the hashing technique works. Because in blockchain, hashing is a very important aspect and it's a process of converting the input data of the transaction of any length to a unique fixed length value. And that value is a hash value. So these obtained hash value is actually a digital fingerprint form of your actual input data or the transaction that you are sending it into a block. Now, how this works? Let's understand very simplistically. I've tried to demonstrate this not through a Python code, but through a command line so that we can interpret every statement and understand how and what is happening actually in that algorithm. So let's start with that. I'll start a Python interpreter and import a hashlib library of Python. Why I'm using hashlib is because Bitcoin also uses hashlib. We can use Bitcoin uses SHA-256 as a hashing algorithm for encrypting their messages. Now we have other encryption forms of hashing like MD5 or Landman, etc. There are multiple techniques, but because this is a very well-known technique of SHA-256, and I found a lot of materials on learning in this, hence I am trying to use this SHA-256. You can choose to work on whatever algorithm hashing and cryptographic hashing that you want to work on. So let's start. So I've imported this hashlib and I'm going to initiate an instance of this object hashlib, and that instance is hash value, and that hash value will be, like I said, an instance of this object hashlib, and we'll use SHA-256. Now this hash value instance which I have created, let's let's update that hash value with some message. So I'll use the update method, and this update method we are going to pass a string that could be anything as a message. Let's say hello Ali. Okay. Now what are we going to do is, this string is a data and this is required to be sent in some form of byte, right? So we need to stream it in the form of byte. So I'll need to encode it. And for that, I'll use this method called encode. And the encoding that we do is UTF-8 in this case. Okay. So we have created an instance out of this object hashlib, which is in the form of using a library hashing library SHA-256. And then I passed a value string value in an encoded form. And now if I want to see the output of that, we can just use hash digest. We have seen this in many other videos and learning articles. So you are familiar with this. This is a hexadecimal code, or a hash value rather. Now this is his cryptographic hash is a kind of a key that makes a blockchain possible, right? Because every block in a chain is embedded into another block through a hash value, through a hash string. And these cryptographic hash, you can think of it as a cipher. So let's say you want to write a message to someone that you know. So you sort of scramble a message and send it to them. Now when you send it to them, you have some sort of key available that would help you unscramble that message. So this is a two-way. So ciphers are two-way functions, but hashing is a one-way cipher, is what you can think of. As it wouldn't go back to the original state that it was. That means from the hash value, you cannot derive the original message. That is hello Ali. From this value, there is no way that, or no mechanism that I can derive this original message back. It will always remain encoded. Okay, so that is why hashing is a one-way function. And these are seemingly random values that are generated. Now the fact that these cryptographic hash value is an absurdly large number is due to the fact that SHA-256 algorithm has 2 to the 256 power possible. What that means is from 2 to the 256 power possible. So which means that we will have a value as large as this. So any data you put will give you anything as a unique value up to this maximum possible value. Right. So this is what SHA-256 does. That is the reason 256. We have 512, but in this example, I'll use 256. So I presume so far we are on track and you at least got a view of what and how this hashing works. Now in the context of mining, how to mine a block in a blockchain. Now we saw that our hex digest is just a number. So what we can do is apply a difficulty to our blockchain. Now, however, more or less, let's assume arbitrarily, we'll just accept blocks whose hash value is a certain specific number. Now, this specific number could be a maximum possible hashing. Out of this maximum possible hashing value, that is 2 to the power of 256. Now, we can say, let's say, if for mining my block in my example, right, I'm going to accept a hash that has a value that is 2 to the power of 256 minus 10 as a difficulty. What I'm trying to say is 2 to the power of 256 minus 10. This is the difficulty I want to set. So any value that is, so any hash value for my block to mine a transaction, the hash value has to be less than this. Okay. And now but first thing we have to convert this hex digest into an integer value. Okay. So we have to specify this in base 16 form. How do we do that? We have seen that in previous examples, right? So I'll just say hash value dot hex digest. This is our converted into base 16. And this value, hash value, has to be something less than 2 by 256 minus 10. Now this is my difficulty level. It says false, which means the hash value is not meeting the condition, the required condition that I want. So that means my block will continue mining until it reaches true or it passes the difficulty requirement. So how do you make it satisfy our difficulty requirement? And what we'll do is we'll add another, just an arbitrary piece of data which we can manipulate, and this so that we can pass this difficulty test of hashes. So let's simple example I'll do. I'll say, let's say trn equals 0. I'll initialize an integer variable, and then I'll set the hash value. I'll create an instance of the object, that is hash library object SHA-256, and then I'll say dot update. And this time what I'll do is I'll pass a string parameter. Okay, last time we said hello Ali. Now this time we'll accept anything that is passed into this trn, and we'll encode that using our UTF, like I showed you earlier. Okay. Now then what we'll do is we'll convert this into a integer using our base 16. Now this base 16 has to be anything less than 2 to the power of 256 minus 10. That is my difficulty. Okay. Now we are getting false over here. So how we will solve this? Okay, how the mining will work. So I'll create a loop. I'll say a while loop. This while loop will keep running until this hash value, okay, this hash value becomes greater than my difficulty level that I have set, which is 256 minus 10. Okay. Then I initialize this, and then it will keep countering, it will keep updating, and the hash value dot update, I'll use the same string, and my integer was trn, which I'm going to convert it into string, and then I'll encode it into, stream it in the form of a byte. So I'll use encode UTF-8, right? And that's it. Now this loop will keep doing that until our hex digest is less than our requirement. That is our until it meets our difficulty criteria or the requirement. Now let's run this and check. Okay, it's less than 2 into 256 minus 10. Now it is true. Now if you want to actually see what this is, why this is true, and I can show you. Now notice one thing. You see these leading zeros? These leading zeros itself significantly tell us and help us identify that the value is less than 2 by the power of 256 minus 10. Otherwise, we would have not got this 00. And this 00 helps us in identifying whether our mathematical condition requirement has met or not. And this is essentially the main part of the mining block. And this is what when we say mining the block, this is what actually happens when we mine a block. So we'll keep hashing each time until we get a hash that suits that difficulty requirement. And once we have that, we have successfully mined that block, and then we move on to the next one. So I hope that this video helps you understand how hashing and mining technique works in a blockchain. So thank you for watching.